Okay, 8.4 is ellipses. I like to think of ellipses as squished circles. So we want to talk a little bit about circles before we start on ellipses. Now remember, for circles, our equation was x minus h squared plus y minus k squared equals r squared. So our center was at hk, and our radius, we would take the square root of that number and just draw a circle. So let's pretend we have a circle. Let's say x squared plus y squared equals 4. Then we would know that the center of that circle would be at 0, 0, because there isn't an h or a k. And the radius would be 2. So we would graph that circle by counting the radius up, down, left, and right, and we would have a circle like this. So what I want you to recognize is that this is 2 units and this is 2 units. So we could do it all the way around, but they're all 2. Well, now we're going to have an ellipse. And our formula will be x minus h squared over a squared plus y minus k squared over b squared equals 1. So let's notice the differences between these two. In circles, this was equal to a number, and we liked it when it was a nice number like 4 because you take the square root of it. In ellipses, the number out there will always be 1. Another difference is in an ellipse you have denominators. So you have numbers underneath these things over here that you don't have in circles. The denominator is always 1. Okay? In both sets of problems, the numbers that are in front of the parentheses need to always be the numbers 1. So we never have a coefficient in front of there. Now when we were working on circle problems, we would occasionally have some when we completed the square, maybe 2x squared. Oh, let's do it this way. Let's use that same example. You could have, if you divided everything in this problem by 4, you would get x squared over 4 plus y squared over 4 equals 1, which would look like it's supposed to be an ellipse. But what you notice is both of these bottom numbers are the same. If they're the same, you're going to create a circle. Because what these bottom numbers will do is determine how far to count for these two spots. And so you're going to count the same number. It's actually going to be the square root of that. So 2 and 2, that's going to make a circle, not an ellipse. An ellipse is a squished circle. So what would one look like? Well, if you squished this circle, it could possibly get squished from the top. So instead of being 2 all the way around, you might squish it down to a 1, 3 type setting, and you would see you get an ellipse. So some people call them ovals instead of squished circles. But I just want to do a comparison between circles and ellipses. All right, let's take a look at the first example or some of the definitions in the notes page. Okay, again, the definition is a set of all points in a plane that the sum of the distances from two given points called foci, which are focuses, plural, is constant. So once you have the picture, we can talk about that definition. Standard form of the equation, again, you have these bottom numbers, which we are going to call a and b. It's a plus sign, and it needs to equal 1. Things to know. X and h are still partners, y and k are still partners, because hk will always be the center of the ellipse. It has to be equal to 1, and it needs to have a plus sign. Now, some of the most important things to know is this right here. That a squared, whichever number is bigger in this bottom spot, is going to be called your a squared. So it doesn't matter, it can be over here or it can be over here. That's going to be your a. The a is important because just like in parabolas, a gives you the direction. Now if you look back at that other example that I gave you, Some people would say, well, this is kind of like a parabola here, and then another parabola here. Well, we know that inside parabolas we have foci, okay, but there's two of them, so that would be a focus and that would be a focus, so we have two of those now called foci. So that's what those are. All right, the long part, okay, is called the major axis, and the short one is called the minor axis. So you might have an oval this shape. This one would be longer than this one. So the pink one would be the major axis, and the orange one would be the minor axis. Now we can have that oval go this way as well. Okay, so this pink one would be the longer one, major, and the orange one would be the short one, that would be the minor. Okay, the intersection point of these two is always the center. Okay, and that's always going to be your HK. So what we got to figure out is how long the pink one is and how long the orange one is, and then we can draw that. Just like in a circle, we only could go up, down, left, and right, and put those 4 dots. Well, you notice now those two numbers are going to be different. In a circle, those two numbers would be the same. And then our foci, there's 2 of them. They're inside the ellipse because they need to be inside the parabola, and they're always going to be on the longer one, on the major axis. Okay, and we'll just call those F. So in here somewhere you'd have these foci points. Okay? One more thing I want to show you before we start an example. I just need to draw a bigger picture. So let's say we have this ellipse. We know that our major axis is this long one. Our minor axis is the short one. The center is where they intersect. And we would have foci points on both sides there on the major axis. This distance on the pink will always be A. The orange distance will always be B. And the distance from the center out to the foci will be letter C. Now, which one of those is always going to be longer? It's going to be A. So we're going to need to know this equation of B squared plus C squared equals A squared. It's important to know which one's longer, but that will always add up to A. And you're going to need to know that formula. Okay, we'll do one example and then we'll do the rest in class tomorrow. All right, when you look at this problem, the first thing you want to figure out is where is the biggest number on the bottom. So 16 is bigger than 4. So 16 is going to be A squared. So what's A? Well, the square root of 16 is 4, which makes B be 2, because it's square root. Now, what's the center? Well, there's no parentheses up here, so the center is just 0, 0. So it doesn't move. So the center is here. This is the A. Okay, so the direction, you want to look up here, and this is Y. So since that's Y, the direction is vertical, meaning it's going to be this kind of an ellipse. Okay, we're going to call this kind of an ellipse horizontal. All right. The next thing you want to do is figure out what C is. So we use this little formula, and all we remember is that C is smaller than A in this problem because it's inside the parabola. That's foci. Okay. B is the short one, and A is the long one. So that's why you use B squared plus C squared equals A squared. So B squared is 4. Plus C squared equals 16, so C squared equals 12, so C equals the square root of 12, which is 2 root 3. Now because we want to graph that, we want to know what that is about. And 2 root 3 on your calculator is about 3.5. Okay? Your major axis is your long one. So that's going to be 8 because it's always 2a. It's double that. Your minor axis is always 2b, so 2b would be 4. So we just go ahead and graph that. Your major axis is in the vertical direction, so you're going to go up 2, 3, 4, and down 4, and then left and right 2. And then the best you can, you draw your oval. Now your foci points are 3.5 about. So 1, 2, 3.5 would be in here and in here. And I just mark them with an F because they're going to be in weird spots. Alright, but you just put them in about the right spot. They should always be inside, so you'll know if you've gotten this number wrong. Now we need to name that point. So just like we've been doing, our center is 0, 0, and I went up 3.5, and I got that from 2 root 3. And then I went down 2 root 3. So that's going to change our y. So our 2 points are 0, 2 root 3, and 0, negative 2 root 3. They're probably going to write that together, and you can do it either way. It would be 0 plus or minus 2 root 3. All right, I want to make sure we understand. This distance is A, this distance is B, and the distance out to the F is C. That's going to be important for us. All right, we'll do the rest of these examples in class.